speaker is Sam Hands, and he is doing automatic scientific Python pipelines with Doit. He's a PhD student working in medical imaging.
Hi, everybody. Can you hear me all right down the back? My voice is going. I just want to make sure. All good? You can hear me? Cool, thank you. All right, so I'm going to put the acknowledgements at the start because I want my voice to actually be working for this part. I'm talking about PyDoit. That's the website. That's the author. I'm also acknowledging that Rob Beagree's software carpentry's lessons on Doit because A, they were my first introduction to Doit and why I started using it, and B, because I borrowed some of his outline for that particular lesson to start this talk off. Okay, so what am I talking about when I say a pipeline? I mean, in most science and stuff, we have data, raw data. Maybe it's from a medical imaging machine, maybe it's from a remote sensor, maybe it's from a satellite, maybe it's from some custom instrumentation thing. And at the end, we have our results. What I'm talking about is what you do in between your raw data to your results. What's the magic steps in between? So what I'm talking about in a pipeline is the bits we do to get from our raw data to our results. Or for most people, that's the sciencey bit. That's the bit we're interested in. Now, this is obviously a really important step because A, you should be able to replicate it. You should be able to get some new data. You should be able to run it through your pipeline and get through the same things. You should be able to recover in the sense that if your laptop dies, you should be able to recreate your results. Like if you've submitted a paper with a bunch of figures in it, it's reasonable to expect that you could recreate those figures given your code and your data. So what I'm talking about is, in Doit, is a tool for automating that process, for automatically combining everything, so that you don't have to worry about it. You don't have to worry about what the manual steps are. You just let it do its magic and figure it all out for you. And this isn't a new idea. It's actually a very old idea, and it kind of goes into the idea of a build system. So Make is the classic example. The reasons I don't want to, I was looking for something other than Make, and I'm not going to survey all of the possible tools. I'm just going to talk about Make and Doit because we don't have all day. The reason I didn't want to learn Make is because it's its own domain-specific language. I don't really want to learn a new language just to automate some tasks. I already know Python. I like Python. I don't want to learn a new language just to make some stuff happen. The other reasons I was interested in Doit is because it is pure Python, so I don't need to learn a whole new language. I can make stuff happen without doing too much effort. There's not a lot of cognitive burden. I don't have to remember some strange syntax. I don't have to differentiate between tabs and spaces and all that other stuff. I know what Python is. So in the context of a pipeline from data to results, there's a lot of ways you can make this reproducible and repeatable and all that other things. If it's a really simple pipeline, you only have a touch of data, say it's a small CSV file, and you've only got one figure at the end. This is easy. You just write one script that loads the file, does some stuff, prints out another file. You don't need to worry about it anymore. But for most people, it's a lot more complicated than that. You have a series of intermediate steps. I mean, as in our medical imaging example this morning, it's not just here's the data, here's the result. It's data goes through some pre-processing, goes through some other analysis, and then we visualize it. It's not one step, it's a series of steps. And as talked about in our middle sessions in calling other functions, it's usually not just one. It's rare that you're working with just one tool. You actually have a bunch of tools, and they may be in different languages, and you need some way to combine them all together to get your final result. So I'm talking about Doit. So Doit, I really like it because it seems verbose. If you used to Make, I think a lot of people would think this is a lot of writing, but once you get used to it, it's a lot more readable. So what I have here is I have a task. So a task in Doit is just a unit of work that has some output in the form of targets, so that's the file we expect to come out. Some actions. In this case, it's just using wget to download the file from a web server. And I'll talk about up-to-date in just a little bit more. I could also have, this task could also depend on other files, in which case I'll show you in the next part of this example what I mean by that. But all a Doit task is a dictionary with a bunch of named key value pairs. So targets, actions, up to date. There's a few other ones that I might mention. I'll just give the other half of this first example. So we have a second task, which is going to use that function, which I'm not showing you the full thing, just assume that that plot temperature function exists. It's going to, given it has a dependency on that file we've just downloaded, we're going to call that function, and we're going to create a plot from that file. And I'm just going to give you the example for this. So I have this already. Doit is mostly a command line tool, but I'll talk at the end that you can also use it through its Python API, so you're not limited to just the command line. By default, it looks for a file called dodo.py, but because I want to show you a couple of examples, I'm explicitly telling it, let's load example1.py. So if I run this, it tells you that I downloaded something really fast because I put it on my laptop to make sure that the internet works. So it's run, there's a lot more output than I remember. So it's run 2 tasks. The first one called download data, it gives you a single dot to tell you that's running. All the rest of that is just the output of wget. And then after downloading that, it's run plot temperatures. So it's run the first part of our first task, which is just to download the data, and then it's done the actual plotting work after downloading it. And if we actually have a quick look, hey, look, it's plotted some data for us, which is Brisbane temperature for June. So this is from the UQ's School of Geology, I think. I will have a full listing of the code and stuff I'm using in this sometime on the web. So what this has done is I've put all of this in this function and those 2 task functions. Doit interprets like nose tests, anything that begins with task, it treats as a task, and it's going to iterate through that. It's going to run through your file, extract everything that's going to be a task. It looks at your dependencies, your targets, works out what tasks depend on other tasks, and then runs them in the correct order. It's implied in this that you don't have any cyclic dependencies, in that it all has to be a nice chain. You can't just have a loop of stuff. That'll give it problems. So the important part is you define a task like this. You let Doit figure out what order it needs to run, what dependencies it needs to figure out, and it does all of the work for you. So you don't need to actually tell it to run anything. You just say, here's the tasks I have, and it does the rest for you. And of course, I mean, this is a bit verbose. I've repeated a bunch of stuff there. So Doit has a couple of niceties to make it a bit easier. Sorry, I'll also point out one other thing. In this first example, I had a shell script. So if in the actions list, it has a string, it treats that as a command, and it calls subprocess, and it runs it out to the shell. So you can integrate, and the other half of this, I've called a Python function directly, so I've given it the function name, the arguments as a separate tuple. In this case, you could also do a list. So you can mix both Python and subprocess and other stuff all in the same file. So you're not constrained to just working in Python, you're not constrained to just working in the shell. You can mix them all together in the way that makes the most sense for your particular project. So when you're doing in the Doit lingo, this is called a command action because it's going out to the shell, and there's a bunch of utilities for handling this in a nicer way, which I'm not going to go into today, but I just want to point out that they exist. So you can use Python's string substitution with percentages. When you run this command through Doit, it'll automatically substitute the keyword targets from the targets of that task. So you don't have to write that particular file name over and over again. But you can substitute it from the actual targets. And also you can use dependencies to get the file dependencies as well. You can also do the same thing for functions, but instead of using string substitutions, you can define your function directly in terms of the dependencies and the targets. So what I mean by this is you write the function you're interested in just has to take the dependencies and targets as arguments, and then you don't even need to tell it anything else. You just say, here's the action I want you to run, and it figures out the rest for you. So I think this is pretty readable. I mean, I'm assuming most of you are used to Python. It's a pretty good guess that that's a function and it's going to do something. So you can do a bunch of substitutions and so on just to generate your task. You don't need to specify hard code everything. You're not constrained in that way. And the other thing is because these are just all Python objects, for example, I've used the string interpolate, the format operator, just to chuck the URL into that particular string. So you can generate your actions and your targets and all those other things in Python. There's much less overhead. You don't have to think too hard about it. You can just write the Python that matches your problem. Excuse me 1 second. All right, so what I defined earlier in something like this is just a single task. But a task to do it is just a dictionary with the right names inside it, and it figures out and it creates its internal representation of the task from that. So you can actually do a lot more complicated things. So just assume, for the sake of convenience, that we have a latest data function which returns lists of file names and URLs for the latest data. In this case, and the example I'll put up on my website, this will download the 3 most recent months data from the web server, the weather data store that I'm talking about. It gets the latest data just by doing some horrible checking what files exist on the server, because I don't think it's automatically updated. They just kind of get added when someone remembers. So it's not a straightforward problem to work out what it is, but there's some horrible parsing and checking headers to see what exists, just to tell me what is the latest data they actually have on the website. But what I've done here is we've extended this example a little bit more. So we're no longer returning a dictionary. This is actually defining a generator of dictionaries in terms of a bunch of data files. So latest data is going to return the information about the 3 latest the 3 latest months of weather data, and for each of those pieces of weather data as separate files, it's going to generate a task to do that action. So this one's just the download and stick them in the data subdirectory. I'll also point out that you need to define a unique name, because Doit uses the name to tell unique tasks apart. So you need a unique name for each task, just so that it knows and can resolve all the dependencies correctly without going crazy. So this will run and download 3 data files and save them into a particular location. This next task is the companion to that. So after we've downloaded some data, obviously we want to go through and read and do the same plot we did for all of that data. So in this case, I can actually tell me what are the data files I actually have present. And I'm going to generate a task for each of the data files in that directory, and each of those tasks is going to generate the graph from that data file. So I have I have an individual task to download each of the latest data files, and then I have an individual task to process each of the data files in that data directory. I'll also just point out that this decorator @createAfter, it's just to overcome one limitation of Doit, and that is when it passes a file, it passes all of the tasks at the beginning and builds up that view. However, if you run this, if you didn't have it, it would build it up, it would find there's no data files in that directory, and it would just download some new ones but wouldn't actually do anything with them. So all that decorator says is, don't try and do it, don't try and even build this task until that other task is completed. So it's just a way of controlling the flow. through that application. So if we okay, so perhaps less impressive when it runs on localhost, unless you like the really big numbers on wget. So it has downloaded 3 data files. It's now going to run through and run a 10-second plot job on each of those data files. And we're going to have the results saved into results, which I'm just going to. So we have April, May, and June plots of the weather. And as you can see, for Brisbane's weather, it's really, really terrible. It's obviously very cold here. We can't stand it. So that's the basic idea. Because you're writing in Python, you can programmatically generate your tasks. Although this is kind of the benefit of having a slightly more verbose syntax for defining a task in terms of a dictionary, is that it actually makes it so much easier to generate all of these bits and pieces. Now, I'm just going to point out a couple of extra little bits and pieces before I forget. So Doit has a whole bunch of utility routines to tell you what's going on. Even when you have automatically generated tasks, you can run Doit list. That subcommand will tell you, these are all the tasks I know about for this particular directory. So if we wanted to, we could then select, say, plot to if, which, for example, we had a much larger chain of 10 connected tasks. We could just say, pick out one of them. It'll execute that one and only the dependencies of that one and not go further through the chain. So you can run, you don't need to do any more work. It's all passed and worked out by Doit. It tells you what tasks you have available. And then you can run specific tasks within that if you just want to look at one piece of it. I'll just point out one more thing. So Doit just keeps a database in that working directory, and that keeps track of the task names, a hash of all of the action dependencies and targets, so it knows what's going on. So that database is how it keeps track of what you've done, what you haven't done, what tasks need to be run later, and so on. So I'll just point out one thing. The last thing I'm going to look at is a real-world example from Nicola. So Nicola is a static website generator, and it uses Doit heavily to actually orchestrate all of the tasks. Because if you're making a static website, then you obviously have things like you'll make a gallery from some images, you'll resize some images to websites, web size, you'll construct the RSS feed. So Nicola is basically just a layer on the top of Doit. So it'll have a bunch of plugins that do something like this. So create galleries just creates a bunch of tasks for each gallery you have defined in your website. So this is an example of programmatically generating all of the bits and pieces you need for your website. And Nicola does this so that you don't need to regenerate the whole thing at once, just the little bits that have changed. And the little bits that have changed are specified by all of the tasks coming out of this. So the main magic in Nicola is it just iterates through all the plugins it knows about, says, give me the tasks you've generated, and then hands it off to Doit. Nicola doesn't actually do any of the work, it just gives it to Doit to fiddle around and make everything happen. So the whole thing is just, the plugins are all define a bunch of tasks, Nicola hands it off to Doit, and it regenerates only the bits and pieces of the website that actually matter. Just a couple of things, I think I mentioned some of them. One is, if you're not on Windows, you can use Doit Auto, and it will automatically watch your directory, and the moment one of the dependencies of a task change, it'll run that one again. That's really nice when you're just trying to refine that tiny little piece of a figure at the end of a pipeline in the format you need for publication. So you change a file, you hit save, and it automatically generates it for you. You can also, if you have independent tasks, you can run them in parallel by specifying a number of jobs. And there's a whole lot more. A couple of things I can think of off the top of my head. If you have a particular task that needs a special something set up in its environment, or needs a special teardown after it's run, you can define those as actions. If you wanted to define parameters that will be passed through to that command on the command line, you can do that with a params key in your task definition dictionary, and so on. So there's lots and lots of little bits and pieces and niceties to make this all happen. You don't have to worry too much about it. You let Doit do all the work. You just specify what the individual tasks look like, and it works out what needs to run when for you. Don't search for Doit. You'll never find anything because it's frustratingly ungoogleable. Try pydoit, otherwise you'll have trouble. I wouldn't have thought that would be a bad name to search for, but apparently it is. That's my email address. I will put the examples I've talked about there eventually when I have time, when I'm not going to fall over. Thank you.
Okay, great. Do we have any questions for Sam?
There's one down the back.
So I've automated tasks in a simple way using Jenkins, and I've avoided doing it in a complicated way using a job scheduler like something called Silk, C-Y-L-C, something, lots of C's. Did you compare and contrast this with any other job automation and dependency management, and what are the relative benefits?
The short answer is I didn't do an exhaustive search. This kind of satisfied my needs very early on, so I didn't want to go down the rabbit hole of A is better than B, but slightly better than C, but maybe D is better for this use case. I liked it because A, it was pure Python. I would just say that the main motivators were it was pure Python, and it didn't require a lot of mental overhead to think about it. I haven't done an extensive survey in comparison to others, so I can't really comment on that, unfortunately.
I'm too afraid to do anything except Jenkins, so that's fine.
Just a little varied question from what Tennessee said. Did you get any chance to also look into the NIPy, which is for the neuroimaging pipelines stuff? Or you have?
No, I haven't, because I'm not doing neuroimaging,
Imaging,
so it
okay.
doesn't quite.
But so you haven't had any experience with that?
No, I have not, unfortunately.
So, that's loud. If you already know Python, what's the overhead to get into Doit? Is it a week? Is it 2 weeks? What would you suggest to people about how long it's going to take them to get up to speed?
Assuming you have a little bit of experience in Python, I don't think that it's less than a week. Assuming you know exactly what task, assuming you know the task you're trying to automate, I don't think it's going to be more than that. If you have less experience, there'll be overhead with learning idiomatic bits and pieces of Python, but apart from that, I don't think there's a lot of overhead. It's certainly not like learning a whole new language from scratch that, hey, it's just used for building stuff. Got one more.
Not really a serious question, but are you familiar with Shia LaBeouf and his Doit performance? It would have been awesome if you started or ended the presentation with a video of him do it.
I will consider that for next time. I'll just do it.
Okay, so unless there are any other questions, I think we can get to afternoon tea a couple of minutes early.